Okay, perfect. Thank you. Okay, good morning to everyone. I am and I am speaking from the University of Twente in the Netherlands, and I'm going to present my research activity of my second year of BA about building and crawl of a double-fed induction generator and the port base of about. Okay, let's see some out of all and some dynamic analysis and qualitative graph modeling of a cascaded induction generator, then the relative indirect field-oriented control applied and some simulation of the system, and the end slides about the work that I'm on about the energy efficient variable stiffness actuator used for commotion deployed robot. Okay, about the cascaded double-fed induction system generator are systems that are widely used in the turbine power plant that use the external torque applied by an external turbine just generate a constant breed in the output. The system is characterized by a shorter shaft that is shared by first one a controlled motor and is going to provide output breed, and another we can change the electrical phase connection just for the torque current ratio. The electric scheme corresponding lefting of an S matrix that is called the rotor phase matrix, by which we change the electrical action of the rotor by changing 3 lambda meters. Starting from this scheme, we had obtained following actions after some mathematical manipulation, and considering also the mechanical part of the system and using a Lagrangian approach, we obtained the following and questions that have been referred to. You can clearly see that the electrical part of the system is directly connected with the mechanical part by using a connection block, and on your left you can see using our transformation matrix that is to change the reference to reference frame, just to let the manipulation be really easy and fast. Then the technique that we have is an indirect field oriented control technique is to obtain a constant voltage stator phases. You can see in this the control scheme that we implemented, in which you can find the PI control and 2 blocks that have to transfer the threads of the states from the normal reference into a rotating prey and vice versa. Then forces speed reference, we are a base voltage of the M1 motor to achieve the goal of the control technique. To prove these results, we have implemented, we have realized a simulated macro block that is composed by a block, an electrical block of the system, and a reduction couple of the mechanical turbine to the mechanical rotor. Left, on your right, sorry, you can see the result tensions, the voltages. The bottom one is showing how the motor is settling on state after a transit, and that the frequency is really cost. And the bottom figures shows how the control variable is referred. It's about the work that I carried during the second year in Modena. Now I will show you something about the work that I'm going to carry on here in the University of Twente. That's about the using efficient actuator for rapid locomotion. On your left, you can see the simple scheme of this kind of variable that uses 2 degrees of freedom that are called QA2 respectively, horizontal vertically. And first one, we are able to change the stiffness of the spring. And with the second one, we are able to the end. The bone graft model is right, and you can see highlight red color, all the energy is connected. The yellow, the output port, the red one is control green one port. That is headline blue. That is a mathematical structure. Resume all the internal information about this, and ensuring in time a sort of energy equilibrium. Now, if we want the stiffness K that is set at the end of the actuator, after some mathematical operation using the Hamiltonian function, obtain that the 2 degrees of freedom 1 and 2 be decoupled and controlled using different control law. That means that if we will be able to control one just for changing the internal stiffness of the system of the actuator and controlling good tracking. The idea is to use this kind of actuator for biped robot motion, but to do that we have to simplify this. Now in this picture is shown a reality was like biped motion. That is, a biped robot is composed by a nest is the green one, 2 legs nest. This kind of robot is walking down on a rope. One leg, support leg, that is characterized by the angle. Okay, and is not supporting, it is swinging around the supporting leg. The movement of the along the slope can be easily described mathematically speaking by a limit cycle that you can show on right. This limit cycle is the mathematical description of the locomotion of the robot. The goal of this kind of research is to define for each kind of value of stiffness a stable limit cycle, the nominal one, and to study what are mathematical conditions that we consider to local orbital stability, to let the robot not fall during during walking. For each kind of sound of walking, for example, from walking to a running. Okay, concluding and some developments about biped robot locomotion. I will work about a new.
Okay, we are losing. Back at the